We are going to find some exact values today. So yesterday, we were just looking at things like this, right? And we had just gotten to the point where we were starting to compose some functions together and noticed that our trig functions will cancel each other out when they are inverses of each other. So if I have sine and arc sine, cosine and arc cosine, tangent and arc tangent, as long as certain requirements are met. When I take a function and I stuff it inside another function, does anybody remember what we call that? If I take a function, like, I don't know, f of x, and I stuff another function inside of it, composition. That's exactly what we've got going on here. I am feeding arc cosine into my function, arc sine into my function cosine. So I need to evaluate this first so that I know what I'm getting from it so that I can do the outside function to it. Do you guys remember that from first semester? We got to do the inside part and then we can do the outside part. Arc sine. Inverse trig functions take in ratios and spit out what? Inverse functions have what as their output? Angles. This will find an angle. Does cosine find angles? For sine, cosine, and tangent, I feed it angles, and it spits out ratios, like root 3 over 2, or, I don't know, 12 over 17. Here's the way I'm going to think about this for just a minute. I know arc sine is going to spit out an angle. I don't know what that angle is, but inverse functions, Pedro, hon, you're going to have to shut it down. Shut it down. Get your notes out, put your phone away. Inverse trig functions spit out angles as their output. So I'm going to name it. Are you guys okay if we name it theta? I don't know what it is, but basically I'm just going to say this is cosine of theta. And if I can figure out what theta is, then I can do cosine of that angle. And then I can get my big answer. So off to the side, we know arc sine of 5 over 13 is the input that I have to work with. This is the same thing as saying sine of theta equals 5 over 13. I don't know what that angle is, but that's what arc sine of 5 over 13 will find for me. Are you guys okay with this so far? Okay. Looking at this, can you tell me what quadrant theta would have to be in? How do we decide? I heard first quadrant. Why first quadrant? Because it's positive. And arc sine is only allowed to look in which two quadrants? 1 and 4. If it's down in 4, sine would be negative, and I'm going to have a negative angle. If it's in quad 1, sine is positive, I have a positive angle. Sorry, I've had a dry tickle in my throat like for the last hour, so if I cough, that's all that's going on. I'm going to draw myself a little triangle. Since I know I would have to be in quad 1, my triangle is going to look kind of like this. Theta is here. How would I label this triangle with what I know about theta? What's my hypotenuse? I'm sorry. 13 is my hypotenuse. What else do I have? 5. Where do I put that? This guy right here. Because sine is y, my opposite side, over r, my hypotenuse. Even without knowing what theta is, if I find this side right here, can you tell me what cosine of theta would have to be? That's just back to geometry class, right? All they did was find a very creative way of telling me what the two sides of this triangle are by saying arc sine of 5 over 13. You're like, okay, arc sine, there's an angle. And when I compare opposite to hypotenuse for this angle, it's 5 over 13. So far, so good? How do I find that side down there? It's 12. How did you know? It's one of the special ones. It's a 5, 12, 13, a Pythagorean triple. So it has to be 12. How could you find it if you didn't know your Pythagorean triples? Pythagorean theorem. Absolutely. So I could always have x squared plus 5 squared equals 13 squared. So x squared equals 144. How did you know it was 12? Because doesn't this come out to be plus or minus 12? First quadrant. In the first quadrant, what's true? Everything is positive. And how did we know this was the first quadrant again? Yep. Sine is positive, and arc sine is only allowed to look in 1 and 4. So if it's positive, it's got to be 1. So what is cosine for this triangle then?
12 over 10.
Absolutely. Cosine of our angle theta would be 12 over 13. That's my final answer here. How we doing? Do we want? Yes, ma'am. Sorry, I could only kind of sort of hear you.
So we take what's on the inside to figure out like the side measurements of a right triangle, and then whatever we like find out missing side, and then we use that as.
If what's on the very inside is an inverse function, arc sine, arc cos, arc tan, yes, we're going to use that to figure out the sides of our triangle.
Okay.
And then we'll find the ratio that it gives me on the outside. In this case, it was cosine.
Okay, got it.
Yep. Sometimes we get lucky and what they give us on the inside is on our unit circle. So we don't even have to draw the triangle.
Yeah.
Those are the nice ones. Those are easier. Sometimes we have to draw a triangle. This one, 5 over 13, not on my unit circle. So I had to draw a triangle there. You guys okay if we move on to number 2? Okay. So I'm going to kind of block this guy off from what we just did so that I don't get confused, because it is sad how often that occurs. Where do I want to be looking first? Inside. So I'm looking right here. That is an inverse function. Inverse functions spit out what? Angles. Do we know what that angle is? Not yet. I don't know where on the unit circle inverse sine is √3. I wish I did. If this was inverse tangent, I could do it. But I can't do it for inverse sine because I don't have just √3 as a sine value. So I'm going to need to draw a reference triangle here. What quad are we in? What quad are we in? 1. What are my only choices when I'm talking about arc sine? 1 and 4. It's not negative, so it has to be 1. So I'm in quad 1, so I'm going to draw my triangle. What do you want to call this angle? Do you want to call it theta again, or do you want to call it something different? X? Sounds fine to me. So that means what I'm after then, sorry, I like picking different colors so that I can see it, means I'd be looking for tan of x then, right? If I'm going to call that angle x. Okay, so how do I take the information they gave me about arc sine and label this triangle? What does sine tell me? Opposite, y, over adjacent, which is r, right? I have to have a fraction. Do I have a fraction? Hanani, I liked your answer. You're like, sort of. Put it over 1, and then it turns into a fraction. I can take anything and put it over 1 and force it to be a fraction. So here's y, and here's r. So my radius is 1, and this is radical 3. Is that one of those nice Pythagorean triples? No. I need this, because I'm supposed to write tangent for this, so I have to have opposite and adjacent. Okay, so whatever this is squared plus radical 3 squared is equal to what? 1 squared. Question mark squared plus 3 equals 1. So this thing that I'm looking for, when I square it, I get what? -2. We have a problem. What's my issue? Yeah, if I take the square root of both sides, this is imaginary. Do we know how to do trig functions with imaginary numbers? Nope. We're only working with real numbers. If you decide you really like math, or you want to be an engineer, someday, way off in the future, you'll learn how to do this, but not for a long time. So what would tangent of this triangle be if I can't find that third side? Undefined. I need some more room. We're going to make you just a little bit smaller. Do we understand why it's undefined? I saw like 2 head nods and not a lot else. Kind of lost, Nicole? Yeah. Okay. Do Do you understand where I got the values on the triangle from? Okay. So when I take and just substitute it into Pythagorean theorem, this side that I'm looking for, I just used a question mark for that. So I squared square root of 3, I got 3. I squared 1, I got 1. When you do this, I'm going to subtract 3 from both sides. I get that this thing squared is a negative. Something multiplied by itself came out to be a negative number. What can you multiply by itself and get a negative? Nothing. The only thing that does that is I, because I times I is -1. That's our imaginary number. Does that make more sense now?
Yeah.
Okay. Get that out of the way so that I'm not cluttering up my next problem. Let's try this with number 3. Focus on the inside function first. What type of a function do I have in there? Inverse function or regular trig function? Inverse. Inverse tangent. I'm looking in which quadrants, and I'm only allowed to look there. 1 and 4. Is this in 1 or is this in 4? How do you know? It's positive, so it has to be in 1. The only way it could be in 4 is if it's negative. Do you know from the unit circle where tangent is 1/2? I can tell you where cosine is 1/2. I can tell you where sine is 1/2. I have no idea where tangent is 1/2. That's not on my unit circle. It will find an angle, though. I just don't know what that angle is. You guys okay if I call this one alpha? All right, so really what I'm looking for here is sine of this angle that I don't have yet. Which means I do what? Draw a triangle. You said I'm in quad 1, so I know it needs to look kind of like this. Here's my angle. I'm going to call it alpha. They gave me what inverse? Inside those parentheses, it's inverse tangent. Tangent is what over what? This is y over x. Sine over cosine. Y over x. Or you could write down opposite over adjacent, right? So I'm going to label my triangle. What do I put over here? 1. What do I put down here? 2. So how do I find this side? Equals r squared, right? So I have 4 plus 1 equals r squared. So 5 equals r squared. So what is r? Square root of 5. So why are we not doing the plus minus thing here? There's 2 different reasons. One, I'm in quad 1. Everybody's positive in quad 1. Second reason, though, what's true about r? R can't ever be negative. X can be negative, y can be negative, r can never be negative. Can you tell me sine for that triangle? 1 over square root of 5. What'd you say, Alex?
Do you have to rationalize?
We do. So I'm going to multiply top and bottom by radical 5. So sine of whatever this angle is equal to what? Square root of 5 over 5. How are we feeling about this? So-so? Because honestly, I'm okay with so-so right now. Okay. First time we've done like actual composite functions with trig functions and inverse trig functions. There's a lot of moving parts here. I'm going to put up a screen that has 5 examples like this. We're going to do at least the first one together. And then I'm probably going to give you guys the other ones to work on individually for a little bit, and then we'll compare answers. Okay? I want to do the first one together, though, because I've changed it up on us. What is on the inside of these parentheses? Sine of 4 pi over 3. Does this find an angle? Sine takes angles in, and it spits out ratios. We'll find a ratio. Is 4 pi over 3 on my unit circle? Score. Shortcut time. 4 pi over 3 is on the unit circle. Okay, so I'm going to keep this inverse cosine. What is sine of 4 pi over 3? Negative, I'm sorry, I didn't hear you. Negative root 3 over 2. Inverse cosine takes ratios and spits out what? I'm looking for an angle as my final answer here. What quads am I allowed to look in for cosine? 1 and 2. Which quad is this one going to be in? 2. And you knew that because it's negative. So looking in the second quadrant, where does cosine have the ratio of negative 3 pi over 2? 5 pi over 6. On your composite functions, do the inside part first, and then use that information to find the outside function. I want you guys to work on 5, 6, 7, and 8. You are welcome to work with a partner. We're going to compare answers. We're going to go through each one, but I want to give you guys a little bit of time to work with these on your own first, and then we'll go through them together. So 5, 6, 7, 8. We're going to do at least 5 minutes on this on your own. All right. Talk to me about number 5. I'm starting off in here. Arc sine. Do you know on the unit circle where sine has a value of negative 3/4? Then that means triangle time. We're going to find an angle, although I'm not going to put it in radians or degrees or anything. I just need it for my triangle. Do you guys mind if we call this guy beta? Is that okay? All right, so I'm going to have tangent of some angle beta. I haven't drawn my triangle yet because I don't know what quad I'm in. What quad is this going to be in? What are my choices on arc sine? 1 and 4. Which one are we in? 4, because it's negative. So when I go to draw my triangle, I want to draw a quad 4 triangle. So it's pointed down like this. So I'm going to put beta right here. That's a really bad beta. Now how do I label it? What do I do with it now? Yep, I need y and r. So here's y, my opposite side. Here's r, my hypotenuse. I know that the hypotenuse can never be negative, which means it's my opposite side, my y side, that's negative. Is this one of those really awesome Pythagorean triples? I want it to be. Why not? It's got 3, 4. Isn't this a 3, 4, 5? Why not? True, but that's not why it's not a Pythagorean triple. 4 is my hypotenuse. And in a 3, 4, 5 triangle, hypotenuse has to be the biggest side. So this cannot be a Pythagorean triple, even though I really want it to be. So I'm going to use Pythagorean Theorem to figure out what's missing. So x squared plus negative 3 squared equals 4 squared. X squared plus 9 equals 16. So x squared equals 7. So x is plus or minus radical 7. Is it the plus or is it the minus? Why? You're correct. We're in the 4th quadrant, which is on the right side of the unit circle. All my x's are positive over there. Now that I've drawn the triangle, can you tell me tangent for this? Negative 3 over radical 7. Can we leave it that way? Rationalize that denominator. Radical 7, radical 7. So my final answer with a rationalized denominator would be what? Beautiful. That's my answer for number 5. How we doing? Reasonably okay? All right. Let's look at 6. Starting inside here, inverse tangent of negative radical 3. Is this something that my unit circle can tell me?
Yeah.
Yes. Tangent can be negative radical 3 on my unit circle. I need to know what quad I'm looking in. Tangent can look in 1 and 4. Has to be 4 because it's negative. Now, remember, when we're in quad 4, for tangent or for sine, can I have angles like 7 pi over 4? I have to go clockwise. I'm going to have a negative angle. We're not going all the way around to get to quad 4. I'm going clockwise to get there. So where's this going to be? What'd you say? Negative pi over 3. I want tangent, which is sine over cosine. I want my radical 3 in the numerator. I want cosine to be 1. I know they're both over 2, but those are going to cancel, and I'm not going to have to deal with those. So that is my pi over 3's. Since it's in the 4th quadrant, it has to be negative pi over 3. All right, so I'm finding the cosine of negative pi over 3. Is that something that you can tell me based on your unit circle? What is the cosine of negative pi over 3? It's negative 60 degrees, but what's the cosine value? What's the x part of that ordered pair at negative pi over 3? What did you say? 1 over 2. All my over 3s have a cosine of 1/2. It's just whether it's a positive or a negative 1/2. All your over 3s, cosine is 1/2. This one's going to be a positive 1/2. Let's do 7 and 8, and then we'll call it a day. Tomorrow, we're going to finish up 7.6. We're going to do exactly what we're doing here, practice more of it, only we're also going to throw in secant, cosecant, and cotangent for our inverses. Which is basically just going to work the same way as these guys. It works almost exactly the same as these guys. So if we can practice with these, we got the other ones down. Look inside here. Is this on my unit circle? Do I know where cosine has a value of negative radical 3 over 3? Then that means reference triangle. Cosine is quads 1 or 2. Which quad is this in? 2, because it's a negative. So I'm going to draw my reference triangle. Are you guys okay if we just call this angle theta? Cosine is what over what? X, my adjacent, over R, my hypotenuse. Well, my hypotenuse here is 3. What's my adjacent side? Negative radical 3. So I have negative radical 3 squared plus y squared equals 3 squared. What's negative radical 3 squared? 3. So 3 plus y squared equals 9. Y squared would have to be 6. So y is plus or minus radical 6. Is it plus or is it minus? Plus. We're in quad 2, and sine is positive there. Do we have enough information that you can tell me the tangent for this angle? What would tangent be here? Can I leave it like that? Rationalize your denominator. So what's my new numerator? Square root of 18. Don't forget that negative out in front. So radical 18 over what? Over 3. Can I simplify that numerator at all? Negative 3 square root of 2 over 3, which is going to reduce down to what? Yep, negative square root of 2. All right, let's check this last one together. I know the bell's coming up. This one's nicer to me, though. Why do I like this one better? It's on the unit circle. What is sine of 7 pi over 6? You said negative 1/2? And I want to know inverse cosine of that. What quad am I looking in? 2, because it can only be in 1 or in 2 since it's negative. I'm in 2. Where in quad 2 is cosine negative 1/2? Done. Tomorrow we'll talk about the restrictions for arc secant, arc cosecant, arc cotan, and then we'll just do more problems like this, but where they're all mixed together. All right?